What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram. Drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best. Okay, let's start. Okay, this is Trigonometry 9.4 in your textbook, Graphs of Trigonometric Functions. Okay, if you got any question or anything unclear, just type it in the chat. Okay, so the main three graphs that we'll be learning is sine, cos, and tangent. Right? From last time also, you all learned your SOHCAHTOA, then sine, cos, tangent. But we've actually never learned on how the graph looks like. Okay, so we need to try to make sense of it. If I give you any kind of sine graph, like maybe sine x plus 1, or sine 3x, or 5 sine x minus 2. Okay, so right now you can actually just put it into a graphing calculator, which is what we normally use, the desmos.com. Then the graph will come out. Okay, or we can actually derive from the formula and sketch it out. So for your IG, you all would need to know how to actually sketch it out because they will test you on it. Okay, so three graphs. I want all of you to try practicing this. Yeah, so we're gonna start with sine and cos first. Sine and cos, right? They are actually like, I like to say they are actually like cousins like that because they are related to each other. Okay, it's just a shift of it. So let's look at the first graph first. Okay, so everyone take out an empty paper, draw an x and y axis. Okay, you all might want 3 of it lah. Later we draw the tangent also. Okay, we normally want to see one whole cycle, okay, which is 360 degrees. So this is x and y. X and y. Let's draw the sine graph first. Okay, as you'll see in your textbook, you see the sine graph is like a wave like that. Okay, if you see also it's like a S shape like that. So sine is S, so S shape. Okay, so what are the main things that you need to write to even sketch out the most basic trigo graph? Put your angle in intervals of 90. So you all look at the x-axis, 0, 90, 180, 270, 360. Right? So you all draw this first. Okay, right? 0, 90, 180, 270, 360. Okay, the next main points that you need to write is your y-axis. The main value for a basic graph will be 1 and negative 1. Okay, 1 and negative 1. Okay, all done, huh? Okay, so for the very first graph that we're going to be drawing is y equals to sine x. It's going to be a shape where it looks like an S like this, S shape, and you start from 0. Okay, so the main points, if you all see, and how to actually get this graph, right? You all go and type in your calculator. You see, what is sine 0? Okay, I want everyone to use your calculator. So type what is sine 0, you get 0. Okay, next value. You see, your x-axis is all the angles. The next value you type sine 90. What do you get? 1. Make sure it's in degree mode also. So 1 is here. Okay, so let's just put an X or a dot there. I want you all do for every single value. Okay, sine 180, sine 270, and then sine 360. Okay, you will get sine 180 equals to 0, sine 270 is -1, sine 360 is 0. Right? Okay. So a sine graph, right, is literally you plotting every single point. It's same like any other graph also. Okay, you plot every single point and then you'll come up to a shape. So if we were to plot every single point from sine 0, sine 1, sine 2, it might be even 0.5, every single point, it will normally give you a smooth shape. Okay, not a straight line. So your shape will be like this. You connect all the dots, but then make it smooth. So this is what you all just did, is you all drew a sine graph. Okay? Later we will practice this a little more also, but we get familiar with this basic one first. Okay, same thing for cos graph. Draw intervals of 90 degrees for your x-axis. Your y-axis, put 1 and -1. Okay, 1 and -1. And then I want y'all do the same thing. Go and find what is cos 0, cos 90, cos 180, cos 270, and cos 360. Then put a dot or an X on top of all the points. Okay. So y'all will see, right? It's like a mountain. Okay, I don't know what shape it is. Okay, but it's like a U like that. Okay. So what y'all need to memorize for this is a cos shape will give you like a U shape like this. Okay, so go and connect all the dots, but make it smooth. Okay, like this. Okay, it's like this, from like that, then like that, then like that, like a U. Okay, but not U, but it's you see the side also. When as it reaches the maximum point, the gradient will change also. Okay, it gets less and less steep. Okay, so what you just did here is a y equals to cos graph. Okay, so what we just drew, right, we call this one period. Okay, so you all need to know few of these terms. You all will, for those who do science also, you all will come across these few terms when you all do physics. Okay, I'm gonna tell you all or teach you all what exactly is the relationship. But let's get familiar with some of these terms first. So what we just drew is one whole period. Okay, period. That means one cycle. One period is equals to 360 degrees. Okay, or we can say one period is equals to 2 pi if we count it in radian. Okay, another term that you all need to know is amplitude. Okay, amplitude. What is the meaning of amplitude? It is the distance between a maximum, or minimum point and the principal axis. Principal axis means your middle axis. It's not always 0 because sometimes your graph might shift. Okay, so just remember principal axis means like the middle of your entire graph. Okay, so in short, the amplitude over here is here from 0 to 1 because your principal axis right now is x, or from here 0 to -1. So which is 1 also lah. The value of it is 1. So we can say the amplitude for y equals to sine x graph is equals to 1. Not from bottom to top, from middle to bottom or middle to top. Both also, you can see it that way. Same goes for cos x also. So cos also here 1, here 1. Okay, so your amplitude is 1. So we learn 2 new terms. First one, period. Second one, amplitude. Okay, let's look at page 196. You all see the sine and cos graph. What we just drew is actually just from 0 to 360 degrees. However, it doesn't stop here. Okay, you can go on and on. That means if I put my period, right, as infinity, okay, from negative infinity to positive infinity. So what will happen is that it will just keep repeating this cycle over and over again. Okay, you go up, go down, go up, go down, go up, go down. Okay, and if you observe, right, so let's continue this lah. Okay, I just roughly draw here. So over here, then here the negative side also you can draw. Same goes for cos also. It will be the same thing. Okay, I never draw. I can't draw very accurately here, but okay, just get the idea that it keeps on continue over and over again. Okay, what y'all cannot observe about the sine and cos x graph? When y'all see the pattern of it, is it the same or not? It's the same, right? Actually, the graph is exactly the same. Okay, the shape of it is exactly the same. If I don't consider the degrees, the angle. Okay, but now let's consider the angle. What is the difference between both of it? The shape is exactly the same, but if you see the sine and cos graph, they have a difference of 90 degrees, right? It's like the graph as if we use sine x as the base graph, cos x is as if it moved to the left or to the right. It doesn't matter how you see it. Okay, maybe to the left by 90 degrees, right? That means you cover your sine x graph. You start from 90 degrees. Okay, let's continue again. Okay, so sine and cos graph, they are like cousins. Okay, because they are actually related to each other. Okay, so if you see a cos graph and a sine graph, it's actually the exactly same shape. It's just a shift of 90 degrees. Okay, so recognize this pattern because you all might need to use this knowledge and to see how it's related to each other. Okay, the last graph that we'll be learning is tangent graph, how to sketch a tangent graph. So I want you all to draw one again. Yeah, draw a x and y axis. Then same thing, plot or write your 90, 180, 270, 360 first. Okay, everyone needs to be writing this because you all need to learn how to sketch it out. Okay, this one is a y equals tangent graph. Okay, the next thing that we're going to draw is called the asymptote. Okay, hold on, write down your degrees down there also. The next thing we're going to draw is the asymptote. So we learned, right, the term asymptote, it means like the floor is lava. Okay, the graph will never touch the asymptote. So there are two asymptotes in one period, meaning within 360 degrees, there are two asymptotes, and the asymptote is 90 degrees and 270 degrees. So you draw the asymptote first. So I'm going to draw it in red here. Okay. Once you finish drawing this, the shape, okay, why is it asymptote also? Y'all go and type in your calculator. You see tangent 90 and tangent 270 degrees. Look at the value. What do you get? Both are math error, right? Because there's actually no value of tangent 90 and tangent 270 degrees. Okay? So, the next thing that you want to do, go and sketch it out. The graph is actually like this. Okay, for now, I just go and sketch it out like this. Okay, so it'll go very, very close to the 90 degrees, but you'll never touch. So you go to until positive infinite y, but it will curve like this. And then for here, the middle part, we draw like this. Okay, this shape. And then the last part, from 270 to 360, like this. Okay, so this is how it looks one period for a tangent x graph. Okay, cool. Okay, so what you all need to observe here is that the graph, right, there's no amplitude here. So there's no maximum point here. And the shape of this graph, it's like this, like this. It also keeps on repeating. So if we extend beyond 0, that means the negative side, and beyond 360, your graph will actually repeat over and over this shape. So you see like this. Okay, I don't know what shape is this, right? This shape. Well, what does it look like? Like a nice curve, right? Okay, so this curve, it keeps on repeating over and over again. Then of every 180 degrees interval, you will have an asymptote also. So over here, if we were to extend some more, here again, another asymptote. So your next asymptote will be 270 plus 180. So here will be at 450 degrees will be your next asymptote. Same goes for the negative side also. Okay, here is negative 90 degrees. So it will keep on repeating over and over again. All right. So in exam, right, what they will be testing you on, they will give you a certain interval. It's not always 0 to 360 degrees. Sometimes they may give you to the negative side, sometimes beyond the positive side, sometimes maybe just half a period, maybe 180 degrees. Then they will ask you to sketch it out. Okay, you can always use the calculator to find the exact value. However, you would need to know the exact shape, okay, on how it bends and all. So like the sine one is like this. Cos also like this. Is sine and cos actually about the same lah. But tangent is totally different, and you will need to draw your asymptotes. Okay, so sketching of sine, cos, and tangent graph in the recent papers, it has been coming out, so you all better know how to sketch this out. So we'll be sketching quite a bit on this. Right now, we even have software like the Desmos. So if when you all do the exercise at time, if you all are unsure how the graph looks like, you can always just type it into Desmos, and then the graph will appear, which is this next part here. Okay, so there are 3 different elements. If we put a number into your trigo function, and then it will change the position or the amplitude or the period. Okay, so Now let's look. Y equals to A sine bx plus c, y equals A cos bx plus c, and y equals to A tangent bx plus c. Meaning, how would a value of A, B, and C affect the sine, cos, and tangent graph? Okay, how would it change? The principles of it actually all the same one. Okay, A will affect it a certain way, B will affect a certain way, C will affect it a certain way. However, we still need to know what is how the original graph looks like first. So make sure you practice these three graphs. Okay, know how to draw these three graphs. Okay, let's look at the first one first. Okay, I want you all to open up your Desmos also. Okay, so that you all can practice with it. Okay, now we're gonna draw these the graphs of y equals to A sine bx plus c, y equals A cos bx plus c, and y equals to A tangent bx plus c. So we're going to analyze how would each A, B, and C affect the graph. Okay, I want all of you to try the first one. The graph of y equals to A sine x. So let's just focus on how the value of A would affect the graph. Okay, so you all go to Desmos right now. Go and type y equals to sine x first, your original graph. Okay, then your second equation, you type y equals to 2 sine x graph. Okay, y equals to 2 sine x. Okay, so you all should get the graph something like this. Okay, if this is your original one, maybe I draw smaller. The value of A would affect your amplitude. Okay, but your cycle is still the same, right? Yeah, I draw until quite ugly lah. But you'll see if we do a y equals to 2 sine x graph, so your blue one, this one, blue one is y equals to sine x. Your red one is y equals to 2 sine x. Okay, so what can we conclude from here? We can conclude that the value, if it's in front of the trigo, it will affect the amplitude. So by the x number, by the a number of times. So if we call it a sine x, so y equals sine x and y equals to 2 sine x, what will happen? Yeah, this one very ugly lah. Okay, like this. It's supposed to just be 2 times lah, the amplitude. Okay. Then here is negative 2. Okay, so what you all need to know is if there's a value in front of the trigo, this also actually applies for cos also. It will stretch the graph. Okay, if the value is more than 1, then it will stretch by that number of times, by the a number of times. So I want you all to guess, if let's say I were to give you all y equals to 3 sine x. Okay, just think in your head, y equals to 3 sine x. How would the graph look like right now? It'll be, your 1 will be 3, right? So you always base it with your original graph. So your 1, now you times 3. And your negative 1 also times 3. Okay? So actually, right, if we were to count every single value, all in the middle also, all also will be times 3 and the y value. Okay? Your x value still remains. So it only affects the y value of it. So that is how the value, if you put it in front here, your a this is how it will affect your entire sine or cos graph. Okay, you all can use your graphing calculator, go and play around with it. Also, go and type y equals to cos x and y equals 2 cos x, y equals 3 cos x, y equals to 10 cos x. You all will observe that the period will be the same, but your amplitude will be stretched. Okay, same goes also if you put a value that is less than 1, then it will be shortened. Okay, it will be shortened. Okay, let's look at the second case. So this is the first one. This is how A affect. What if I put the value, the graph of y equals to sine bx. Okay, now I want to put the integer, the value, inside the angle there, sine bx. So sine bx or cos bx. I want all of you to try right now. Okay, go back to your decimals. Now take away the 2 in front. Instead of putting sine 2 sine x, now you all put sine 2x. Okay, sine 2x. Looks a bit more complicated right now. Okay, what can you all observe here? Okay, what can you all observe here? I want you all to ask yourself that. If you all look, the amplitude is exactly the same. Okay, the amplitude is exactly the same. However, now your period is different, right? So your period has been changed. So how does it change? You have to ask yourself, how does it change? Okay, if you all see, now they are actually, your one period right now is 180 degrees. Okay, one period means one whole cycle, one whole sine graph. If you all see, within 180 degrees, one whole complete sine graph has already been completed. Okay, so I'm going to draw this. Okay, this is a y equals sine x graph first. Y equals to sine 2x graph. It looks something like this. 1, 2. Okay, by right, the amplitude all should be the same lah. Okay, so what will happen here? The value inside, right? If my value I put it inside, 2x means I will have 2 cycles in 360 degrees itself to complete. Yeah, to complete one whole cycle. Okay, so that's how the graph will affect it. So y'all can see also in your textbook. Okay, it should give you the same value. Okay, so y'all type into decimals also. This is something that you all need to know. So in exam, they will actually test you all, like they say, go and sketch y equals to sine 3x. Sometimes it might be the other way also. They give you the graph, then ask you to determine the value. Okay, clear? This one, the second one. So if I put my value inside the angle, how would it affect it? If it's 2, means I will have 2 cycles inside within 360 degrees. If I have 3x, means my period will be 120 degrees. That means one whole cycle will be 120 degrees. I will be able to fit 3 cycles. Okay, so there's some calculation also. So you all can see it has been stretched from the y-axis with a stretch factor of 1/2. The amplitude of sine 2x is 1, and the period is 180 degrees. Meaning, it will now be half already. I want to fit 2 cycles, 2 periods. Okay, I keep saying cycle because it's used for, last time I learned the term of cycle. 2 periods within 360 degrees. So my one period is 180 degrees. Okay, so in a way, the value inside is the balik one. If it's 2, then I need to 360 degrees divided by 2. If it's 3, then I need to take 360 degrees divided by 3. Okay? So this is how you do the second case. The third case, let's say if I were to draw the graph of y equals to sine x plus c. Okay, y equals to sine x plus c. Okay, go type into your Desmos again. Then see how does the graph look like. Okay, go type it into your Desmos. Draw your original one first. So draw a y equals to sine x graph. And then if you see, your entire graph, right, is shift up by 1. Okay, so original just now got the original is 0, 1, and -1. So what will happen is your entire graph right now, okay, your new principal axis will be now 1. And your graph will look okay, like this. Wow, this one slightly so nice. Okay, so smooth. Okay, so your highest point right now is 2, your middle is 1, and your lowest point now is 0. Can you all see it? Okay, so what is the logic of this? Sine x plus c means the c value, it will shift the entire graph, okay, by up or down. Okay, so it will be shifted up or down. So this is a y equals to sine x plus 1 graph. The logic of this, you can apply it for your sine, cos, and tangent also. Sorry, tangent actually, because there's no amplitude, so it will probably only affect the period. Okay, so it won't affect the amplitude. Okay, so to summarize it, okay, later when you all do the exercise, then you all might need to, at the start, you all might need your graphing calculator in front of you, so you all can understand the logic. But in conclusion, this is how you will affect the graph. Y equals to sine bx plus c, then y equals to a cos bx plus c, and then y equals to a tangent bx plus c. Okay, so we need to know how different things would affect the graph differently. So for a, it will affect the amplitude. Okay, same goes for this a also. So your value of a, if it's 1, then it will be the same. If it's 2, then 1 times 2. If it's 3, then 1 times 3. So your amplitude. Okay, remember what's the definition of amplitude? The distance between your principal axis and your maximum or minimum point. Okay, second one, the value of b, it will affect the period. Okay, affects period. How to calculate the period? 360 degrees. Instead of multiplying, this one is divide by the value of b. So if I want to find what is one period of, let's say, sine 2x, one period means you complete one whole sine graph. In a 180 degrees range of angle, you will see one whole complete sine graph already. And the last one, your C, it will shift your entire graph. So we call this vertical translation. It will shift the entire graph up or down. Okay, vertical translation. Okay, so this one is shift graph up or down. Okay, so same goes for tangent also. The B, okay, the B, the same thing, affect the period. However, C also same thing, but we actually this one can't really see also lah. Okay, but A, it doesn't do anything because there's no maximum or minimum point. So A will only be significant for sine and cos graph. B, your period. So how you calculate one period right now is 360 degrees divided by B. C, it shifts your whole graph up or down. Okay, shift your whole graph up or down. Okay? So now, right, we need to be able to join all A, B, and C together and then learn how to sketch a graph. So I want all of you to turn to page 200 right now. Let's learn how to sketch because this is a potential IG question. Sketching trigonometric function. Okay, we have to follow the step by step, and I want all of you to also practice on sketching. Okay, what do they want us to sketch right now? Y equals to 2 cos 3x minus 1, and the angle, the range of the angle is that we want from 0 to 360 degrees. Okay, there's a step-by-step process. So let's say right now you don't have that Desmos with you, you don't have a graphing calculator. So you want to roughly sketch it out to know how the shape looks like. Okay, so you have to do one step at a time. Okay, first one, we always start with the original graph. Y equals to cos x. So I want you all to just roughly sketch. Don't have to sketch when you're so accurate. But you need to get the main points. Okay, meaning you need to know your 0, 90, 180, 270. Yeah, wrong way. Yeah, so draw until so ugly. Okay, let me draw again. Oops. 90, 180, 270, 360, and then 1 and -1. So these are the significant points that you all need to show. Okay, so like a U shape like that, that's the original cos graph. Your period is 360 degrees. Your amplitude is equals to 1. Okay, second one, let's solve what is B first, or let's sketch out the graph of the cos BX. So let's sketch actually A or B you draw first also doesn't matter, but let's just follow the textbook one for now. Cos 3x. Cos 3x means what? Okay, my period will divide by 3, right? So you all go calculate what's the period first. Period equals to 360 by 3 equals to 120 degrees. That means I will get one whole cycle of a cos graph in 120 degrees. So in 360 degrees, I will have 3 cos graphs. Okay, so I draw a bit bigger. So we'll get 1, 2, 3. Okay, 1, 2, 3. You all can see here, here, here. So you have the main points here will be 180 degrees. Over here actually will be 90. And here will be 270. And here 360. Okay, once again, this is just a rough sketch only. Your amplitude is the same, right? Okay, because I haven't changed the value yet. I haven't add the A into it yet. Okay, so this is step 2. All clear? Period 360 over 3. Amplitude still the same. Equals to 1. Okay. Third step, now I want to put a 2 cos 3x. Okay, I lazy draw another one. So I just add, because the only thing that it will affect, right, is your amplitude, which is your 1 and the -1, right? So I'm just going to put it in red color here. How would it affect? So this is actually step 3. Okay, this is step 2, step 3. You all can draw another one again. But how it will affect, it will look exactly like this. However, my amplitude now will be 2. So it becomes 2 like this. So 2 and -2. Okay, so this is the third step on how you change the graph, or how the A will affect the graph. Okay, let's look at last step. Number 4 is we want to -1. So what will happen? -1 means your whole graph will be shifted down by 1. Okay, so now only you draw this 2 cos 3x minus 1. What are the important points here? You all see your 2, your 0, and -2. So 2 minus 1 will be 1, 0 will be -1, -2 will be -3. So this is how I like to think about it. I draw a bit bigger here. Okay, so I would draw the middle point, so which is your principal axis. So here will be 1, -1, and here is -3. So I will always draw this principal axis so I know where is my middle. Okay, this is what I will do. And then the graph is the same. 1, 2, 3. Okay, I draw not according to scale. Okay, but here will be 360 degrees. Then the middle here, 180 degrees. And then here, 0 degrees. Okay, so this will be a y equals to 2 cos 3x minus 1 graph. Clear? Okay, so you all have to follow the step on how to sketch this out. However, in exam, right, they will basically they will give you these values. If they ask you to sketch it out, sometimes actually you can just use the calculator to find the main value. So like you put 2 cos 3 times 90 degrees, then you find from 0, 90, 180, 270, 360, then you can find every single value. Okay, then you just connect all the graph, the shape of the graph, but you need to know how the graph looks like first. Okay. Okay, what example 6 and 7, I want you all to try by yourself first. I'll go through the next lesson because I need to prepare for something. Okay, so today what we learn is the drawing of graph. Okay, the drawing of graph. You all need to know this part here. Have the graphing calculator in front of you so you can double check it, but not to just use it and then sketch, then just copy it. You need to understand the logic of the A, B, and C. Okay, so refer to what I just taught you all. Just refer to the A, B, and C. It will always be the same one. Okay, on how you shift the graph, how it affect the period, how it affect the amplitude, and how it will shift the graph, which is your C value. Okay. Sorry for the technological error just now. Okay, I also didn't plan for that. Suddenly the electricity trip. Okay, go and try work example 6 and 7. So you all are supposed to finish until exercise 9.4 for the holidays. Okay, so after holiday, I will probably spend another 2 more lessons to go through the entire chapter so that you all are familiar with this also. All right, cool. All good. Okay, practice. Don't slack during the holidays, but at the same time, happy holidays. This is your only holidays, and then when you all come back, it's a new term and a new year already. All right, see y'all in 2 weeks' time. Goodbye. Thank you very much. See y'all.
Thank you, Chap.
Bye bye.